All right, so this is the 2019. This is the NCEA 2 Year 12 Algebra External Exam. This is question 1e. And the question 1e asks, use algebra to show that the graph of the function blah, where c is not equal to 0, crosses the x-axis at two distinct points. And you can actually see that it does this already. Even if a and b were equal to 0, even if they were equal to 0, which means that the graph would actually therefore cross there like there. If that were true, and this is y, and this is 0, and this is x here, if that were true, because c is not 0, and it's squared, and it's like if it was -5, for example, -5 squared is suddenly going to be positive 25. And now we're going to subtract the whole thing by 25. So it's going to drag this whole thing down to whatever number it is. And suddenly it's crossing at two distinct points. So this is set up in a way that it doesn't matter what you do. And that's really what it's asking. Can you show that it doesn't matter what values you give, A or B or C, it's always going to cross at two distinct points. So even if A and B was 0, because c squared is not 0, and it's squared, and it's subtracted from the other part of the expression, it has to cross at two distinct points. And that's really what the argument here is. So let's go ahead then. And the one thing we've got, the one tool at our disposal, is the discriminant. Of course, the discriminant we can actually force to actually position itself in such a way that it's going to be greater than 0. So the question is this whole thing here greater than 0? Well, let's actually position it so it does. So let's go ahead, let's expand it out, and let's then find the discriminant value of this, which is going to hopefully confirm this idea here. So let's go ahead and do that. So first of all, I'm going to rewrite the equation, which is y is equal to, and I always like rewriting them, because it means I've got to write it a bit bigger. Minus c squared. There it is. All right. So it gives me more room to mess around here a bit. So all that's equal to, I've got an x times x, which is an x squared. And negative a times negative b is going to be positive ab. That's going to have a negative c squared on the end, of course. It's going to have a negative a and a negative b. Minus a minus b. Minus, sorry, ax. Sorry, that's an ax. And minus, it's minus bx. All right. So if we're going to use the discriminant, we need coefficients of x squared, x, and x to the 0. So what are those? Well, x squared, there it is. You can see the coefficient is going to be a 1. The coefficient of x, well, I'm going to put plus x. Here it is. And what is the coefficient going to be? I'm going to put it on the right side. Normally you wouldn't, of course. But negative a times x makes negative ax, and negative b times x makes negative bx. And that all works fine. And then I've got this bit on the end here, which I'm just going to go plus ab minus c squared. So I can see now my coefficients. My coefficients of x squared is going to be 1, so a is 1. Looks like 0.1, sorry, that's a dot made by the printer. Okay, b is going to be the coefficient of x to the 1, is x to the 1, and it's going to equal negative a minus b. And c is going to be everything that's left, which is ab minus c squared. There it is. All right, let's throw it into the discriminant, which is b squared minus 4ac. I'm going to check to make sure that things work out if it's going to be greater than 0, and if it really is. So let's have a look. So we've got b squared, which is minus ab, minus a minus b. In fact, I'm going to write it out twice because I'm just going to set it up so I can just multiply it straight out. Minus 4 times a, well, a is 1. I'll put times 1 just so I have done it. C is minus r. I'll put this on one in brackets so I can, because I have to multiply a few bits here. Let's multiply all this out. I've got a times a, which is a squared. Negative b is b squared. And I've got negative ab and another negative ab, which is negative, positive. These are positive. A times b is, negative a, negative b, positive b. It's going to be positive 2 lots of ab plus b squared. This is minus 4 lots of this thing here, which is a, b minus c squared. Let's expand all that out. So I've got my a squared plus my 2ab plus b squared minus 4ab minus, or sorry, plus, negative times negative is plus 4c squared. All right, so this actually, for those in the know, of course, this is a completed square. But let's go ahead and actually, let's complete the square for this thing here in terms of a, because we're dealing with, a's. And let's see if we can take the 2 bit, because really this is 1 bit on its own. Let's make them into 2 separate and clear expressions. So let's complete the square here. So I'm going to take the a here, so it's going to be a squared plus 2ab. Oh, wait. No, before we do that, I think we should collect like terms so we can see what we're actually doing here. So we've got a squared. I've got 2ab minus 4ab is minus 2ab plus b squared plus 4c squared. All right, so now that's better. So now we've condensed it a little bit more. Let's go ahead and complete this part of the square. So this is a squared minus 2ab. Now I'm going to take the b term, which is negative 2b. This is all in terms of a. So negative 2b is the coefficient of a, really. So I'm going to go plus that bit there. And then over here I'm going to subtract it, yes? So I'm going to go negative 2ab. So this is going to be negative 2b all over 2, all squared. I got plus b squared here. Minus 4. Oh, sorry. Then I'm going to take this thing again, and I'm going to subtract it from both sides. So it's going to be minus b, 2b onto all squared. And I got my plus 4c. There it is, 4c squared. Okay, hopefully that looks good. Now what we're going to do, because if I do this here and I do this here, the net value of that is 0. If I add negative 2b on 2 all squared and then subtract negative 2b on 2 all squared, it's as if I haven't done anything and I'm still dealing with this expression here. So let's go ahead and put an equals here and see what happens. So now all of this here very happily turns into a, and the bit in here, negative 2 divided by 2 is going to be negative b all squared. That's my completed square now. And now I've got this bit on the end here, which is a plus b squared. Now what's this thing here? Negative 2 divided by negative 2 is minus b all squared. Minus b all squared is minus b. So I've got minus b squared plus 4c squared. And of course, that is equal to, I've got my a minus b all squared. B squared minus b squared is 0, and I end up with a plus 4c squared. So now we're in the situation, and of course, the whole thing is greater than 0. Of course, b could still be 0, yeah? In which case, if b was 0, then this thing would actually equal 0. So therefore, a minus b squared, it could be 0, but it also, if b is not 0, it's going to be greater than 0, because it doesn't matter what you do in here. If you take a negative number and you square it, it's going to be greater than 0. So either this is going to equal 0 or it's going to be greater than 0. And we've got 4c squared. It doesn't matter what you do with 4c squared, because you're squaring something, even if it's negative, that's definitely going to be greater than 0. So therefore, I'll use that dot there. Therefore, values a and b are either equal or greater than 0, and 4c squared is going to be greater than 0. Therefore, graph must be above, not above, must, let's say, cross x-axis at 2 distinct points. And I think that's what we need to say, yeah? Yeah. And I think the way we need to also justify this is because really A and B, we're talking about the roots, yeah? And I put because A and B constitute yeah, I would say two real roots. Yeah, so that's what I would put, and that would be my answer.